Okay. Good morning, all of you. So in last lecture, we have discussed about the general heat conduction equation. So whatever the derivation part of that particular equation, we have discussed, and we get the equation of the general heat conduction equation in Cartesian coordinate system. So this is the general heat conduction equation in Cartesian coordinate system. Okay. After that, we have discussed about the different forms of the general heat conduction equation. Okay. So in that first form, we have discussed when the thermal conductivity is constant. Okay. So whatever the three directions are there, x, y, z. So we have to consider in the thermal conductivity will be constant. Means kx is equal to ky is equal to kz is equal to k. Okay. So by using this, we get the one equation that is nothing but general heat conduction equation. Dou square t upon dou x square plus dou square t upon dou y square plus dou square t upon dou z square plus qg by k is equal to rho c by k into dou t by dou t. Okay. So this is the general heat conduction equation in Cartesian coordinate system. Okay. So as we know that thermal diffusivity is nothing but thermal conductivity divided by thermal capacity. Okay. So we have put this value into this equation and we get the equation as a 1 upon alpha. Okay. So this is the general heat conduction equation. After that, we have considered the different conditions. Okay. In first case, we have to consider that internal heat generation is not there, means qg is equal to 0. So we have put the qg is equal to 0 into this equation, and whatever the equation we got, that is nothing but Fourier's equation. Okay. So this is the Fourier's equation. In second case, we have considered the steady state. So as we know that change in temperature with respect to time, that quantity becomes 0. So therefore we get this equation, and that equation is nothing but Poisson's equation. And similarly, in the third case, we have considered there is a no internal heat generation and steady state condition, means qg is equal to 0 and dou t by dou t is equal to 0. So we have put that value into equation number 2, and we get this equation, and this is nothing but Laplace equation. Okay. So these are the different forms of the general heat conduction equation. Okay, in Cartesian coordinate system. Then we have discussed about the derivation heat conduction through a plane wall. Okay, so we have considered one plane wall having thermal conductivity is K and having thickness is L. Okay, so our aim is to calculate the equation for this Q, whatever the rate of heat transfer takes place through this particular plane wall. So our aim is to calculate the equation for that. Okay, so for that we have considered that general heat conduction equation, and we are assuming the some conditions, that is qg is equal to 0, then one dimensional heat flow is there. Okay, because in this case we are considering only x direction, so therefore we have considered the one dimensional heat flow, and heat conduction is at steady state. Okay, so therefore dt by dt is equal to 0. So these are the assumptions for this derivation. When we are putting this value into this equation, we get this equation as a dou square t upon dou x square is equal to 0. Okay, so we have considered for the small element. So now we have to derive the equation for the plane wall. So whatever the partial derivative is there, we have converted that partial derivative into total derivative. Okay, so we have taking the 2 times integration. So by taking integration, we get this equation t is equal to c1x plus c2. Okay, and after that we have applied the boundary condition. So what are the boundary conditions? At x is equal to 0, temperature is T1, and at x is equal to L, temperature is T2. So by using these boundary conditions, we get the constant values. What is the value of C2? That is nothing but T1, and what is the value of C1? T2 minus T1 divided by L. We have put this value of C1 and C2 into equation number 3. We get the equation of the temperature. Okay. So this is the equation. By using that, we have to calculate the temperature at any location of that particular plane wall. And our equation of the heat transfer rate is Q is equal to minus K into A into dt by dx. So in this equation, we have, first of all, we have calculated the value of dt by dx by using this equation number 4. And by using that, we get the equation of the Q. So what is our final equation? Q is equal to K into A into T1 minus T2 divided by L. So this is the equation. By using that, we have to calculate the heat transfer rate through the plane wall. Plane wall मधून जर तुम्हाला heat transfer rate calculate करायचा असेल तर तुम्हाला हे equation use करावं लागेल. Okay. In the form of thermal resistance, we get the equation as a Q is equal to T1 minus T2 divided by thermal resistance of the conduction. So from this, what is the thermal resistance of conduction? L by K. Okay. So that part we have covered in the last lecture. Now we have to discuss the composite wall. So what is the meaning of composite wall? So already we have discussed, derived the equation for the single plane wall. Now we have to combine the different plane walls. Okay, so what is the meaning of composite wall? A built of combination of two or more units of different types of materials that are bonded together. Okay, so what if there is different materials are there? Suppose this is the A plate, this is the B plate, this is the plate C. Okay, so what is the thermal conductivity of plate A? Ka. What is the thermal conductivity of plate B? That is Kb. And what is the thermal conductivity of plate C? That is Kc. Okay, so what is the meaning of composite wall? A wall built up of combination of two or more units. दोन किंवा दोन पेक्षा जर मोर युनिट आपण कंबाईन केले तर त्याला काय म्हटलं जातंय? प्लेन वॉल म्हटलं जातं. समजलंय? Already we have discussed or we have derived the derivation for the single plane wall. Now we have to derive the equation for the if there is a composite wall. And what is the meaning of composite wall? A wall built up of combination of two or more units of different types of material that are bonded together. Okay, so this is the composite wall having three materials are there. Okay, so each material having different thermal conductivity. Suppose this is a plate A having thermal conductivity is Ka. This is the plate B having thermal conductivity is Kb, and this is the plate C having thermal conductivity is Kc. Okay, so now our aim is to calculate the rate of heat transfer through this composite wall. Okay, तर ही जी composite wall आहे त्याच्यामधून किती rate of heat transfer होणार आहे ते आपल्याला कॅल्क्युलेट करायचं आहे. त्याच्यासाठी आपल्याला काय करायचं आहे? We have to find the equation for this particular composite wall. Okay, so all of you write down what is the meaning of composite wall. Write down composite wall. Write down composite wall. Composite wall. A wall built of a combination of a wall built of a combination of two or more units. A wall built of a combination of two or more units of a wall built of a combination of two or more units of different types of material that are bonded together. दोन किंवा दोन पेक्षा जास्त मटेरियल ज्यावेळेला आपण बॉन्ड करणार आहे त्याला काय म्हटलं जाते? कंपोजिट वॉल. ओके, अ वॉल बिल्ट अप of a combination of two or more units of different types of material that are bonded together. Okay, so in practicals also there is a one experiment. Find out the thermal conductivity of composite wall. Okay, so there also we have to use this equation, and by using that we have to calculate the rate of heat transfer for the composite wall. Okay, so write down heat conduction through a composite wall. Heat conduction through a composite wall. Our aim is to calculate the equation for the finding the rate of heat transfer through this composite wall. Okay, so all of you write down heat conduction through a composite wall. 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 Okay, so here we have considered the three slabs. This is slab A, this is a slab B, and this is a slab C. Okay, so our aim is to calculate the equation for this Q. Okay, so whatever the amount of heat is conducted into this composite wall, that same amount of heat is conducted out from that element. म्हणजे जेवढी काय हीट आतमध्ये जाणार आहे तेवढीच काय होणार आहे? बाहेर येणार आहे. So our aim is to calculate the equation for this Q. Okay, so already we have calculated the equation for this single plate. Single plate साठी equation काय असते सांगा? What is the equation for the single plate? Already we have calculated that equation, or we have derived that equation. Q is equal to what? K into A into T1 minus T2 divided by thickness. म्हणजे ह्या प्लेट A साठी जर कॅल्क्युलेट करायचं म्हटलं तर थिकनेस काय असणार आहे? LA. Okay, so now we have to understand three slabs are there: slab A, slab B, slab C. What is the thickness of slab A? That is LA. What is the thickness of slab B? That is LB. and what is the thickness of slab C, that is LC. Okay, thermal conductivity of plate A is K, plate B is KB, and plate C is KC. Okay, and we have assumed this condition: T1 is greater than T2, T2 is greater than T3, and T3 is greater than T4. Okay, so already we have discussed the derivation for this simple plane wall. So what is the temperature profile for the plane wall? Temperature profile कसा असते प्लेन वॉल साठी? स्ट्रेट लाइन, जे काय आपल्याला इक्वेशन मिळालं होतं, whatever equation we got, it is in the form of y is equal to mx plus c. Okay, so therefore we have draw this straight line here. Okay, what is the temperature profile for the plane wall? That is nothing but it is a linear or it is a straight line equation. Okay, so that's why we have draw this straight line. So what is the temperature for this plate A, T1 and T2, for plate B, T2 and T3, and for plate C, T3 and T4. Okay, so now I have to write down the equation for the plate A, plate B, and plate C. Okay, so before that we have to write down these things. Consider the transmission of heat through. Consider the transmission of heat through a composite wall. Consider the transmission of heat through a composite wall consisting of number of slabs. Consider the transmission of heat through a composite wall consisting of number of slabs. Consisting of number of slabs. Consider the transmission of heat through a composite wall consisting of number of slabs. So all of you draw this diagram. Okay, we have to consider the three slabs are there: slab A, slab B, and slab C. Okay, what is the condition for the temperature? T1 is greater than T2, T2 is greater than T3, and T3 is greater than T4. Then what is the thickness of the slab A? LA. What is the thickness of slab B? LB. And what is the thickness of slab C? That is LC. Okay, and Q is nothing but amount of heat is conducted into this composite wall, and same amount of heat is conducted out from that composite wall. Okay, so in the left hand side we have to write down the Q, and in the right hand side we have to write down the Q. Okay, and in the resistance form we have to draw the diagram also. Okay, Q amount of heat is transferred through this composite wall. What is the thermal resistance of slab A? That is thermal resistance of slab A. What is the thermal resistance of slab B? That is R thermal B. And what is the thermal resistance of plate C? That is R thermal C. Okay, and what is the temperatures for the slab A? T1, T2, for slab B, T2, T3, and for slab C, T3, T4. Okay, so we have also draw the resistance diagram. Okay, diagram is over. Okay, so can anyone tell me, suppose Q is 100 joule per second, rate of heat transfer is nothing but 100 joule per second. So how much amount of heat is transferred through the plate B? कसं कॅल्क्युलेट करणार आहे? मी काय म्हणतो, इकडून मी 100 वॅट एवढी हीट ट्रान्सफर केलेली आहे, इकडे पण आपल्याला 100 वॅट मिळणार आहे. म्हणजे प्रत्येक प्लेट मधून जे काही हीट ट्रान्सफर होणार आहे ते काय असणार आहे? 100च असणार आहे, सेम असणार आहे, लक्षात ठेवा. So whatever the heat transfer is takes place, that is Q. So that Q amount of heat is transferred through the each plane wall. Okay, so Q amount of heat is transferred through the plane wall A, then plane wall B, and plane wall C. So that's why at the right hand side we get the rate of heat transfer as a Q. प्रत्येक प्लेट मधून सेमच heat transfer होणार आहे. We have to consider that. Okay, then write down the things. What is the meaning of LA, LB, LC? Write down thickness of slabs A, B, C respectively. Okay, so write down the meaning of LA, LB, LC. What is the meaning of LA, LB, LC? Thickness of slabs A, B, C respectively. Ka, Kb, Kc, thermal conductivity of metals A, B, and C. then T1 T2 temperature at wall surface 1 and 4. Okay, इथं आपण नाव दिलेली आहेत. ही phase 1 आहे, phase 2, phase 3 and phase 4. Okay, so according to that we have written the temperatures. T1 and T4 is nothing but temperature at wall surface 1 and 4, and T2 and T3 is nothing but temperature at interfaces, that is 2 and 3. First class again. LA, LB, LC, KA, KB, KC. What is the meaning of T1, T4, T2, T3? Okay, so these are the parameters of that particular composite wall. Meaning of the each term. What is the meaning of LA, LB, LC, KA, KB, KC, and what is the T1, T4, then T2, T3? Okay, so Q amount of heat is transferred through that particular composite wall. Okay, so whatever the heat transfer is takes place through the plane wall A, whatever the heat transfer is takes place through the plane wall B, and whatever the heat transfer is takes place through the plane wall C, that is same. Okay, so according to that we have written one statement. Since the quantity of heat transmitted per unit time through each slab is the same. Since the quantity of heat transmitted per unit time, since the quantity of heat transmitted per unit time through each slab is the same. What? Since the quantity of heat transmitted per unit time through each slab is the same. प्रत्येक स्लॅब मधून जी काय हीट ट्रान्सफर होणार आहे ती काय असणार आहे, सेम असणार आहे. कारण लेफ्ट हँड साइड ला आपण Q लिहिलेला आहे. We have written at the right hand side also Q. So whatever the heat transfer is takes place through each slab, that is same. Okay, so after that we have to write down from Fourier's law. What is our standard equation? Q is equal to minus K into A into dt by dx. Okay, since the quantity of heat transmitted per unit time through each slab is the same, then write down from Fourier's law. From Fourier's law, Q is equal to minus K into A into dt by dx. Q is equal to minus K into A into dt by dx. Okay, so now we have to write down the equation of the each plate. So whatever the plate we have considered, plate A, we have to write down the equation. आता आपण काय म्हटलेलं आहे, प्रत्येक प्लेट मधून सेमच हीट ट्रान्सफर होणार आहे, कारण लेफ्ट हँड साइड ला आपण Q घेतलेला आहे. Similarly we have taken at the right hand side as a Q. Okay, so that's why whatever the heat transfer is takes place through each plate, that is the same. Okay, so that's why whatever the heat is transferring through plate A, we have considered the Q. Whatever the heat is transferring through the plate B, that is Q, and whatever the heat is transferring through the plate C, that is also Q. Okay, म्हणजे इथं आपण actually QA लिहिलं असतं, whatever the heat transferring through the plate A, but it is the same. So that's why we have written as a Q for the each plate. Okay, so we have to write down the equation for the plate A. Q is equal to what? So what is the equation of the plane wall? K into A into T1 minus T2 divided by L. So similarly we have to write down the equation for the plate A. So what is the equation for the plate A? What is the thermal conductivity of plate A? K into area. And what is the temperature for the plane wall A? That is T1 minus T2 divided by what is the thickness LA. Okay, similarly we have to write down the equation for the plane wall B. Okay, आपण Q सेम घेणार आहे कारण हीट ट्रान्सफर प्रत्येक प्लेट मधून सेम होते असं आपण कन्सिडर केलेलं आहे. That's why we have taken the Q. Okay, जर सेम नसतं तर आपण काय घेतलं असतं, तर QA घेतलं असतं, तर QB घेतलं असतं, तर QC घेतलं असतं. But whatever the heat transfer is takes place through the each plate, that is the same. Okay, so we have to write down the equations for the plate A, plate B, and plate C. So what is the equation for the plate A? K into A into T1 minus T2 divided by LA. Then what is the equation for the plate B? त्याची thermal conductivity काय आहे? Plate B ची KB. Then what is the temperature difference for the plate B? T2 minus T3. And what is the thickness of the plate B? That is LB. Okay. Similarly, we have to write down the equation for the plate C. That is thermal conductivity is Kc into A. Then temperature difference for the plate C, that is T3 minus T4 divided by thickness of that plate C, that is LC. Okay. आता हे Q सेम आहे. Whatever the left hand side is for these three equation is same. तर आपण काय करू शकतो, Q सेम आहे म्हटल्यानंतर ही प्रत्येकाची व्हॅल्यू काय असणार आहे, सेम असणार आहे. So we have to write down the equation or we have to equate this equation. Means therefore Q is equal to what? Q is equal to this, Q is equal to this, and Q is equal to this. In this form we have to write down the equation. Therefore Q is equal to K into A into T1 minus T2 divided by LA is equal to KB into A into T2 minus T3 divided by LB is equal to KC into A into T3 minus T4 divided by LC. Okay. कारण हीट जी असणार आहे ती सेम असणार आहे, फक्त आपले इक्वेशन काय असणार आहे, वेगळं असणार आहे. पण हे इक्वेशन सॉल्व्ह केलं तर तुम्हाला जी काय व्हॅल्यू मिळणार आहे, ह्याची जी काय व्हॅल्यू मिळणार आहे, ह्याची जी काय व्हॅल्यू मिळणार आहे, त्या व्हॅल्यूज काय असणार आहे, सेम असणार आहे. ओके. सो रिअरेंजिंग अबो इक्वेशन्स. ओके. सो रिअरेंज दिस टर्म. So for this we have to write down the equation for the T1 minus T2. So from this equation, what is the value of T1 minus T2? T1 minus T2 is equal to what? Q into T term इकडे होणार आहे Q into LA divided by this term at the denominator K into A. Okay. So write down the equation. Rearranging above equations. So T1 minus T2 is equal to Q into LA divided by K into A. This is the equation number 1. Similarly, we have to write down the equation for the T2 minus T3, and similarly we have to write down the equation for the T3 minus T4. Okay, so can anyone tell me what is the equation for the T2 minus T3? T2 minus T3 साठी काय येणार आहे, Q into LB divided by KB into A, and similarly we have to write down the equation for the T3 minus T4 is equal to Q into LC divided by KC into A. Okay, so write down the equations. T2 minus T3 is equal to Q into LB divided by KB into A. That is the equation number 2. Then T3 minus T4 is equal to Q into LC divided by KC into A. This is the equation number 3. Okay. Then we have to add this equation number 1, 2, 3. So by adding, we get the equation as a T1 minus T4. बाकीच्या टर्म कॅन्सल होणार आहेत. बघा काय येतंय, ऍडिशन करा. Take the addition of equation number 1, 2, and 3. Okay. Adding equation 1, 2, and 3. So T1 minus T2 is there. Then T2 minus T3 is there, and T3 minus T4 is there. So minus T2 plus T2 will cancel. Minus T3 plus T3 will be cancelled. Okay, इथं addition करा पहिल्यांदा. Q common येईल. So what is the remaining term in the bracket? LA by K into A plus LB divided by KB into A plus LC divided by KC into A. Okay. So minus T2 plus T2 will cancel. Minus T3 plus T3 will be cancelled. So what is the remaining term? T1 minus T4 is equal to what? Q into bracket LA divided by K into A plus LB divided by KB into A plus LC divided by KC into A. Okay. So our aim is to calculate the rate of heat transfer through that particular composite wall. So our aim is to derive the equation for the Q. So whatever the equation we got, so from that we have to write the equation for the Q. Okay. So from this equation, what is the value of Q? Q is equal to what? T1 minus T4 divided by LA divided by K into A plus LB divided by KB into A plus LC divided by KC into A. Okay. So how to calculate the rate of heat transfer through the composite wall? So for this we have to use this equation. If there are 3 slabs are there, 3 slab असताना आपल्याला हे इक्वेशन यूज करायचं आहे. Suppose if there are 4 slabs, what is the changes in this equation? Can anyone tell me? आता हे जे इक्वेशन मिळालेलं आपल्याला, हे कधीचं इक्वेशन आहे, ज्यावेळेला 3 स्लॅब्स असतील त्यावेळेला. समजा तिथं 4 स्लॅब्स असतील तर काय डिफरन्स येईल? T1 minus T5 आणि डिनॉमिनेटर मध्ये काय होणार? इथं आणखी एक फॅक्टर ऍड होणार आहे, एलडी डिवायडेड बाय केडी इंटू ए. समजलंय? तर हा काय आहे, एल ए डिवायडेड बाय के इंटू ए हा थर्मल रेजिस्टन्स आहे त्या प्लेट ए चा. Then LB divided by KB into A. This is the thermal resistance of plate B. So whatever the number of plates are there, according to that we have to write down the thermal resistance. आता मला सांगा, if n number of plates are there, so what is the change in this equation? n number of the plates असतील तर इक्वेशन मध्ये काय चेंज होणार आहे? तीन प्लेट ज्या वेळेला असते त्यावेळेला इथे काय येते, T4 येत आहे. If n number of plates, then what is there? Tn plus 1 means T1 minus Tn plus 1 divided by, इथे किती टर्म येणार आहे? n प्लेट्स असतील तर n नंबर ऑफ प्लेट्स. आता तीन प्लेट्स आहेत तर तीन थर्मल रेजिस्टन्स आहेत. 4 प्लेट्स असतील तर 4 थर्मल रेजिस्टन्स येणार आहे. आणि n नंबर ऑफ प्लेट्स असतील तर n नंबर ऑफ रेजिस्टन्स येणार आहे. ऑल ऑफ यू गेट दिस पॉइंट. सो बाय युजिंग दिस इक्वेशन वी हॅव टू कॅल्क्युलेट द थर्मल रेट ऑफ हीट ट्रान्सफर थ्रू द कंपोजिट वॉल. ओके. आणि टेम्परेचर डिफरन्स बघा, T1 मायनस T4 म्हणजे जे काही एंडचं टेम्परेचर आहे ज्या कंपोजिट वॉलचं ते आपण काय घेणार आहे, न्यूमरेटरला घेणार आहे, T1 मायनस T4. ओके, इथपर्यंत झाले सगळ्यांचं. सो आर थर्मल रेजिस्टन्स ए म्हणजे काय असणार आहे, प्लेट हा जो LA डिवाइडेड बाय के इंटू ए म्हणजे काय आहे, थर्मल रेजिस्टन्स ऑफ प्लेट ए आहे. सिमिलरली LB by KB into A, this is the thermal resistance of plate B. And similarly, thermal resistance of plate C is nothing but LC divided by KC into A. So in that form, we have written the equation as a Q is equal to T1 minus T4 divided by thermal resistance of plate A plus thermal resistance of plate B plus thermal resistance of plate C. Okay. In the form of thermal resistance, we have to write down this equation. How to calculate if the thermal resistance is known to us, as at that time we have to use this equation. Q is equal to T1 minus T4 divided by thermal resistance of plate A plus thermal resistance of plate B plus thermal resistance of plate C. Okay. In the form of thermal resistance, we have to write down the equation of Q. समजले का बघा सगळ्यांना? जेवढ्या प्लेट्स असणार आहेत तेवढे काय असणार आहेत, थर्मल रेजिस्टन्स असणार आहेत. 3 प्लेट असतील तर न्यूमरेटरला काय येणार आहे, T1 मायनस T4. 4 प्लेट असतील तर काय येणार, T1 हा फिक्स असणार आहे, फक्त इथलं टेम्परेचर चेंज होणार आहे. फक्त आपल्याला एंडचं टेम्परेचर घ्यायचं आहे, ह्या एंडचं आणि त्या एंडचं. ओके. देन this is the equation for heat transfer through 3 slabs. If there are n number of slabs, then what is the equation? Q is equal to T1 minus Tn plus 1 divided by summation changes from 1 to n L by K. So write down this equation. If there are n number of slabs, इथे n number of terms येणार आहेत L by K च्या. हे जे इक्वेशन आपल्याला मिळालेलं आहे ते फॉर दी 3 स्लॅब्स आहे. If there are n number of slabs, so at that time we have to use this equation. Q is equal to T1 minus Tn plus 1 divided by summation changes from 1 to n L by K. जेवढ्या काय टर्म्स असतील तेवढे काय येणार आहे, थर्मल रेजिस्टन्स येणार किंवा जेवढ्या प्लेट्स असणार आहेत तेवढे थर्मल रेजिस्टन्स येणार आहेत. If there are n number of slabs, if there are n number of slabs, Q is equal to T1 minus Tn plus 1 divided by L by K, summation changes from 1 to n. Okay, all of you get this point. How to calculate the rate of heat transfer through the composite wall. Plain wall असेल तर काय इक्वेशन येणार आणि composite wall असेल तर काय इक्वेशन येणार आहे हे लक्षात ठेवा सगळ्यांनी. ओके. एकच प्लेन वॉल असेल तर एकच रेजिस्टन्स असणार आहे. ज्यावेळेला 2 किंवा 3 असणार आहेत त्याच्याप्रमाणे आपल्याला रेजिस्टन्स ऍड करायचे आहेत. ओके, झाले सगळ्यांचं? ओके. So now suppose this is the one complex problem. Our aim is to calculate the rate of heat transfer through this complex problem. So how to calculate the rate of heat transfer through this composite problem or complex problem? Can anyone tell me? जसं आपण इलेक्ट्रिक सिस्टीम कन्सिडर केलेली आहे त्या फॉर्म मध्येच आपल्याला काय करायचं आहे, वी हॅव टू कन्सिडर द हीट ट्रान्सफर सिस्टीम. ओके, सो व्हॉट एव्हर दिस प्लेन वॉल्स आर देअर, प्लेट ए अँड प्लेट बी, त्या एकमेकांना कशा आहेत, पॅरलल मध्ये आहेत. ओके, त्याच्यानंतर ही प्लेट आणि ही प्लेट कशी असणार आहे, सिरीज. परत ही कशी असणार आहे, सिरीज. या तीन प्लेट ज्या आहेत त्या एकमेकांना कशा आहेत, पॅरलल मध्ये आहेत. ओके, सो फर्स्ट ऑफ ऑल वी हॅव टू ड्रॉ दी resistance diagram for this complex problem. Then we have to easily understood how to solve that particular problem. Okay, म्हणजे plate A and B are parallel to each other. इथे तुम्हाला खाली दिसतंय plate A and plate B are parallel to each other. Then C and D is series with these two resistances. म्हणजे ह्याचं जे काय आउटपुट मिळणार आहे ते कशामध्ये असणार आहे, सिरीज मध्ये असणार आहे. Okay, for plate C and plate D, and whatever these three plates are there, E, F, G. So these are parallel to each other. Okay, so I will draw the parallel diagram for that, and these three are series with the D. Okay, तर हे समजून घ्या कशा प्रकारे असणार आहे. ज्यावेळेला तुम्हाला अशा प्रकारचा प्रॉब्लेम असेल तर त्यावेळेला तुम्हाला पॅरलल मध्ये कुठले आहेत ते पॅरललचे आन्सर कॅल्क्युलेट करायला लागेल. ओके, देन वी हॅव टू कॅल्क्युलेट दी सिरीज. ओके, सो इन दॅट वे वी हॅव टू कॅल्क्युलेट. म्हणजे थर्मल रेजिस्टन्स ऑफ प्लेट ए काय असणार आहे, what is the thermal resistance of plate A? Can anyone tell me what is the equation for that? Thermal resistance of plate A, standard formula काय आहे, LA divided by K into A. तर इथं हा जो थिकनेस आहे तो काय आहे, LA किंवा LB आहे. म्हणजे हा सेम आहे, म्हणजे LA डिवाइडेड बाय काय येणार आहे, K into काय येणार, एरिया काय येणार, एरिया कुठला कन्सिडर करत असतो आपण, सरफेस एरिया. मग सेम असणार का वेगळा असणार आहे, वेगळा असेल ना का सेम असणार आहे, एरिया कुठला असणार आहे हीट ट्रान्सफर होताना, एरिया विच इज नॉर्मल टू द डायरेक्शन ऑफ हीट फ्लो. म्हणजे इथं कुठला एरिया असणार आहे, एरिया सेम असेल का वेगळा असेल फॉर दिस के अँड के बी. तर प्लेट ए साठी आणि प्लेट सी साठी एरिया सेम असेल का, सेम नसणार आहे, कारण सी साठी आपण पूर्ण हा एरिया कन्सिडर करणार आहे. इथं प्लेट आहे अशी कन्सिडर करा, प्लेट इकडून असं आपल्याला फक्त एज दिसते, हा जो एरिया असणार आहे तो एरिया आपल्याला कॅल्क्युलेट करायचा आहे, द एरिया विच इज नॉर्मल टू द डायरेक्शन ऑफ हीट फ्लो. ओके, सो फर्स्ट ऑफ ऑल वी हॅव टू राइट डाउन दिस, राइट डाउन in order to solve more complex problem, in order to solve more complex problem involving both series and parallel thermal resistance, in order to solve more complex problem involving both series and parallel thermal resistance, involving both series and parallel thermal resistance, the electrical analogy may be used, the electrical analogy may be used, the electrical analogy may be used. Okay, so write down the equation. Q is equal to delta T overall divided by summation of thermal resistance. So this is the standard equation. By using that we have to calculate the Q. Okay, Q is equal to delta T overall. So whatever the complex problem is there, so we have to take the overall temperature difference of that particular complex diagram divided by summation of thermal resistance. ओके, आता इथं बघा थर्मल रेजिस्टन्स ऑफ प्लेट ए, LA डिवाइडेड बाय K into A आपण असं घेत होतो. पण इथं एरिया काय घ्यायचा आहे, त्या प्लेट ए चा एरिया घ्यायचा आहे. म्हणजे हा जो एरिया असणार आहे, व्हॉट एव्हर दिस एरिया, ही फक्त आपल्याला एज दिसते, पण तिथं काय असणार आहे, सरफेस असणार आहे. अशा प्रकारे काय होत असणार आहे, ही ट्रान्सफर होते. आपल्याला फक्त एज दिसते. म्हणजे जेवढी प्लेट ए आहे हा एरिया तुम्हाला घ्यावा लागेल, प्लेट बी साठी खालचा एरिया तुम्हाला घ्यावा लागेल. ओके, सो वी हॅव टू रिमेंबर which area we have to take. Okay, so first of all you have to draw this diagram. So this is the one of the complex problem. So some of the plates are parallel to each other and some of the plates are in series. Okay, so whatever the plates are in parallel, we have to draw the parallel, and whatever the plates which are in series, we have to draw the series diagram. Okay, so whatever the thickness for plate A and B, that is the same. LA is equal to LB. What is the thickness of plate C? That is LC. Then what is the thickness of plate D? That is LD. And what is the thickness of plate EFG? That is the same. LE is equal to LF is equal to LG. LE is equal to LF is equal to LG. Okay, and similarly we have to draw the resistance diagram. Okay, so whatever the plates which are parallel, we have to show the which plates are in parallel. That is plate A and B are in parallel to each other. Okay, so whatever the output we get which is in series with plate C and plate D, then plate E, F, G are parallel to each other. So whatever the output of that which is in series with the plate C, D. Okay, so in that way we have to draw the diagram. So now our aim is to calculate the resistance of each plate. म्हणजे thermal resistance A calculate करायचा आपल्याला. Then we have to calculate the thermal resistance of plate B. Then we have to calculate the thermal resistance of plate C. Then plate D, plate E, plate F and plate G. Okay, जर पॅरलल मध्ये असेल तर रेजिस्टन्स काय करणार आपण सांगा. सिरीज मध्ये जर रेजिस्टन्स असेल तर काय करतोय आपण, if the resistances are in series, how to calculate the output of that particular, फक्त काय करायचं आपल्याला ऍडिशन करायचे आहे. So whatever the thermal resistance are there, we have to add that values. आवडते विद्यार्थी. Okay, so now we have to calculate the value of thermal resistance of plate A. So whatever the plates are there, we have to calculate the thermal resistance of each plate. इथपर्यंत झाले सगळं. Okay, so thermal resistance of plate A काय असणार आहे, LA divided by K into area of that particular plate A. Then thermal resistance of plate B, LB divided by KB into AB. Then thermal resistance of plate C is equal to LC divided by KC into AC. Okay, similarly we have to write down the thermal resistance of plate D, E, F and G. Okay, आता प्रत्येक रेजिस्टन्सची आपल्याला व्हॅल्यू कॅल्क्युलेट करू शकतो by using this equation. Okay, but how to calculate the output of these two resistance? काय करायला लागेल, सिरीज मध्ये असेल तर आपण डायरेक्ट ऍडिशन करू शकतोय, but for the parallel what we do, 1 upon R is equal to what? 1 upon R thermal A plus 1 upon R thermal B. समजते बघा, ह्या दोन्हीचं जर तुम्हाला आउटपुट कॅल्क्युलेट करायचं असेल, सपोज वी हॅव टू कन्सिडर द आउटपुट एज ए R. So 1 upon R is equal to what? 1 upon R thermal A plus 1 upon R thermal B. Okay, so by using that equation we have to calculate the output of these two parallel plates. Okay, आणि इथं काय करायला लागेल, ह्या तीन प्लेटचं आपल्याला काय करायला लागेल, आउटपुट कॅल्क्युलेट करायला लागेल. So in this case we have to calculate by using the equation as a 1 upon R is equal to what? 1 upon R is equal to 1 divided by R thermal E plus 1 divided by R thermal F plus 1 divided by R thermal G. Parallel मध्ये असेल तर काय करायचं, 1 upon R is equal to how many resistances are there? We have to take the reciprocal. ओके, म्हणजे इथं काय करायला लागेल, 1 upon R is equal to 1 upon R thermal A plus 1 upon R thermal B. सिरीज मध्ये असेल तर डायरेक्ट ऍडिशन करायचंय, म्हणजे ह्याचं जे काय तुम्हाला आउटपुट मिळेल प्लस दिस हे काय होणार आहे, सिरीज मध्ये होणार आहे. याचा अगोदर आपल्याला आउटपुट कॅल्क्युलेट करावं लागेल आणि परत ते याच्यामध्ये ऍड करावं लागेल. ओके, सो इन दॅट वे वी हॅव टू कॅल्क्युलेट दी ओव्हरऑल रेजिस्टन्स अँड दॅट व्हॅल्यू वी हॅव टू पुट हिअर समेशन ऑफ R thermal. And by using this equation we have to calculate the complex problem. म्हणजे ज्यावेळेला अशा प्रकारचे प्रॉब्लेम असतील त्यावेळेला तुम्हाला सेपरेट हे रेजिस्टन्स कॅल्क्युलेट करावं लागेल, त्याच्यानंतर ह्याचा आउटपुट कॅल्क्युलेट करायला लागेल, त्याच्यानंतर ह्या सगळ्याची सम घ्यावी लागेल आणि ती व्हॅल्यू तुम्हाला इथं पुट करावी लागेल. And by using that we have to calculate the rate of heat transfer for this particular complex problem. म्हणजे किती पॅरलल मध्ये असू द्या, किती सिरीज मध्ये असू द्या, तुम्ही काय करू शकता, कॅल्क्युलेट करू शकता. All of you get this point? How to calculate the rate of heat transfer for the complex problem. So whatever it may be parallel, whatever it may be series. If series is there, we have to add, and if parallel is there, we have to take the 1 upon R is equal to 1 upon RA plus 1 upon RB. So in that way, we have to calculate the output and then we have to add. Okay. So this is about the complex problem. Then write down the next point as a overall heat transfer coefficient. Write down overall heat transfer coefficient. 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 Okay. So what is the meaning of this overall heat transfer coefficient? आतापर्यंत आपण काय बघितलेलं आहे, फक्त आपण कंडक्शन कन्सिडर केलं होतं. ओके, सो व्हॉट एव्हर दी 3 प्लेट्स आर देअर, इन ईच प्लेट देयर इज ए कंडक्शन. ओके, बट नाउ इन दिस केस वी हैव टू कंसिडर देयर इज ए वन प्लेट, ओनली वन प्लेट इज देअर and at one end there is a fluid and at another end there is a fluid. ओके, म्हणजे आपण मगाशी जे कन्सिडर केलं तिथं आपण 3 प्लेट्स कन्सिडर केलेल्या. So whatever the heat is transferring through each plate, that is because of the conduction. But in this case, we have considering there is only one plate, and at the both side of this plate there is a fluid. Okay, ज्यावेळेला एका प्लेटच्या दोन्ही साइडला फ्लुइड असणार आहे, then how many modes of heat transfer is there? फ्लुइड मध्ये काय होणार आहे? Suppose we have to consider this is a plate A, and at the left hand side of this plate there is a fluid film. म्हणजे इथं कसलं फ्लुइड असणार आहे? हॉट फ्लुइड असणार आहे, and at this side there is a cold fluid. Okay, so heat transfer is takes place from the hot fluid to the cold fluid. Okay, so whatever the mode of heat transfer is there in the hot fluid, तो कुठला मोड असणार आहे? Which mode is there? कुठला मोड असणार आहे? सॉलिड मध्ये कंडक्शन होते असं म्हणतोय आपण, फ्लुइड आणि गॅसेस मध्ये कुठला मोड असणार आहे? कन्व्हेक्शन असणार आहे. ओके, सो whatever the heat transfer is takes place through this hot fluid, म्हणजे hot fluid जे असणार आहे त्याच्यामध्ये जे काही heat transfer होणार आहे ते कशामुळे होणार आहे? Because of the convection. Okay, then this plate, so in this plate the heat transfer is takes place due to the conduction, and after this plate there is a fluid, that is cold fluid. Okay, so whatever the heat transfer is takes place in this fluid because of what? Because of the convection. म्हणजे एखाद्या प्लेटच्या दोन्ही साइडला ज्यावेळेला फ्लुइड असणार आहे त्यावेळेला हॉट फ्लुइड मध्ये पण काय असणार आहे? कन्व्हेक्शन असणार आहे. at the center or whatever the plate is there, in that plate conduction is there, and whatever the cold fluid is there, in that fluid, what will happen? Convection is there. Okay, so we have to write down the equation of each. Okay, म्हणजे ज्या वेळेला आपण कंडक्शन आणि कन्व्हेक्शन सायमल्टेनियसली घेतोय, at that time we have to calculate the overall heat transfer coefficient. समजतंय बघा, मगाच्या इक्वेशन मध्ये आपण फक्त कंडक्शन होतं, त्यामुळे तिथे आपल्याला ओव्हरऑल हीट ट्रान्सफर कोएफिशियंटची गरज नाही. पण ज्यावेळेला कंडक्शन आणि कन्व्हेक्शन ह्या दोन्ही गोष्टी सायमल्टेनियसली असणार आहेत, at that time we have to calculate the overall heat transfer coefficient. समजतंय बघा, when the conduction and convection, these two modes, and sometimes radiation is also there. If all modes are there, so at that time whatever the heat transfer coefficient is there, so that heat transfer coefficient is nothing but overall heat transfer coefficient. म्हणजे आपल्याला काय करायचं आहे, तर त्या ओव्हरऑल हीट ट्रान्सफर कोएफिशियंट साठी काय इक्वेशन असणार आहे, आपण एक कंडिशन कन्सिडर करतोय. इफ वन प्लेट इज देयर, at the one end there is a hot fluid, at another end there is a cold fluid. So for that we have to calculating the overall heat transfer coefficient. काही वेळेला वेगळी सिच्युएशन असेल, एका साइडला फ्लुइड आहे आणि परत दोन प्लेट असू शकतात, तर त्यावेळेला ओव्हरऑल हीट ट्रान्सफर कोएफिशियंट काय? Okay, so we have to calculate the equation of that overall heat transfer coefficient. Okay, so for that we have to write down first what is the meaning of overall heat transfer coefficient. Write down, while dealing with the problem of fluid to fluid heat transfer, while dealing with the problems of fluid to fluid heat transfer, while dealing with the problems of fluid to fluid heat transfer across a metal boundary, across a metal boundary, it is usual to adopt an overall heat transfer coefficient. Overall heat transfer coefficient notation is capital U, and overall heat transfer coefficient bracket मध्ये लिहा capital U, which gives the overall heat transfer coefficient U, which gives the heat transmitted per unit area, which gives the heat transmitted per unit area per unit time, which gives the heat transmitted per unit area per unit time per degree temperature difference between the bulk fluids on each side of metal, heat transmitted per unit area per unit time per degree temperature difference between the bulk fluids on each side of metal, ओके. ज्यावेळेला तुम्हाला हे इक्वेशनचं U चं ज्यावेळेला इक्वेशन मिळणार आहे, त्यावेळेला हे समजेल तुम्हाला डेफिनेशन काय आहे ते. Okay, so first of all we have to solve that equation. We have to find out the equation for the capital U. Okay, so draw this diagram. So we have to consider one plate. At one end there is a hot fluid film, and at the another end there is a cold fluid film. ही dotted line चे meaning काय असणार आहे, इथं fluid आहे असं त्याचं meaning आहे. Okay, so whatever the plate is there, at the left hand side there is a hot fluid film, and at the right hand side there is a cold fluid film. Okay, so whatever the temperature of the hot fluid, that is THF, temperature of hot fluid. Okay, then what is the temperature of the plate, that is T1 and T2. These are the outside temperature of this plate A. Then what is the temperature of cold fluid, that is TCF. Okay, and HHF is nothing but heat transfer coefficient of the hot fluid. आपल्याला माहिती आहे, what is the equation of the convection? Can anyone tell me what is the equation of the convection? Convection चे इक्वेशन बघितलेलं आपण सुरुवातीला, न्यूटन्स लॉ ऑफ द कूलिंग, Q is equal to H into A into TS minus TA. ओके, तो H जो असणार आहे तो काय असतोय, heat transfer coefficient असतोय. So in this case, this HHF is nothing but heat transfer coefficient of the hot fluid, and this HCF is nothing but heat transfer coefficient of the cold fluid. Okay, कन्व्हेक्शन आहे म्हणजे तिथं heat transfer coefficient असणारच आहे. जसं आपण म्हणतो की प्लेट आहे म्हणजे त्याचं थर्मल कंडक्टिव्हिटी असणार आहे. Similarly, we can say if convection is there, then convection heat transfer coefficient is there. Okay, so whatever the hot fluid is there having heat transfer coefficient is a HHF, and whatever the cold fluid is there having heat transfer coefficient is a HCF. आणि प्लेट आहे म्हटल्यानंतर त्याची थर्मल कंडक्टिव्हिटी असणार आहे. सो दॅट्स व्हाय देयर इज ए K. K is nothing but thermal conductivity of this plate A. Okay. आता रेझिस्टन्सच्या फॉर्म मध्ये जर लिहायचं म्हटलं तर काय येणार आहे, हीट ट्रान्सफर रेट काय असणार आहे, लेफ्ट हँड साइडला जे Q आहे तेच राइट हँड साइडला काय आहे तर Q आहे. सो व्हॉट एव्हर द हीट ट्रान्सफर इज टेक्स प्लेस थ्रू दिस हॉट फ्लुइड, through this plate and through this cold fluid, that is same. Okay, so Q. So for the hot fluid, what is the temperature difference, THF and T1? These are the temperature difference for this hot fluid. And what is the thermal resistance? Thermal resistance of the hot fluid. Okay, then thermal resistance of plate A, this is conduction, so thermal resistance of plate A. Then thermal resistance of this convection. इथून इथपर्यंत काय होणार आहे तर कन्व्हेक्शन होणार आहे. इथून इथपर्यंत काय होणार आहे तर कंडक्शन होणार आहे, आणि इथून इथपर्यंत काय होणार आहे तर कन्व्हेक्शन होणार आहे. ओके, सो व्हॉट एव्हर द रेजिस्टन्स ऑफ दिस, दॅट इज thermal resistance of hot fluid. Whatever the resistance in between this, that is thermal resistance of plate A, and whatever the thermal resistance cold fluid, that is thermal resistance of the cold fluid. Okay, so we have to write down the equation of the each mode. So whatever the convection is takes place, we have to write down the equation of the Q. Whatever the conduction is takes place, we have to write down the equation of the Q, and whatever the convection is takes place in the cold fluid, we have to write down the equation. Okay, प्रत्येक मोड मधून हीट ट्रान्सफर होणार आहे. आपण काय म्हणले, Q अमाउंट ऑफ हीट इज ट्रान्सफरिंग थ्रू दिस पर्टिक्युलर सेक्शन. ह्या पूर्ण सेक्शन मधून काय होत्या, Q अमाउंट ऑफ हीट ट्रान्सफर होत्या. म्हणजे लेफ्टला Q आहे, राईटला Q आहे, म्हणजे प्रत्येक प्लेट असेल किंवा कन्व्हेक्शन असेल तिथून हीट ट्रान्सफर काय होणार आहे, Qच होणार आहे. सो देअरफॉर वी हॅव रिटन द इक्वेशन एज ए Q is equal to HHF into A into THF minus T1. कोणी सांगू शकते का हे इक्वेशन कसं आलं? इक्वेशन नंबर 1. Can anyone tell me? Q, आता हे तर माहिती आहे, लेफ्ट हँड साइडला Q आहे, राइट हँड साइडला Q आहे, म्हणजे इथून जी काही हीट ट्रान्सफर होणार आहे तेवढीच हीट ह्याच्यामध्ये ट्रान्सफर होणार आहे, तेवढीच ह्या फ्लुइड मध्ये ट्रान्सफर होणार. म्हणजे Q तर सेम असणार आहे तिन्ही इक्वेशन साठी. म्हणजे इथून इथपर्यंत जी काही हीट ट्रान्सफर होत्या तिथं काय असणार आहे, कुठला मोड असणार आहे, कन्व्हेक्शन आहे. इथं फ्लुइड आहे हे सगळं. ओके, फ्लुइड असेल तर कुठला मोड ऑफ हीट ट्रान्सफर असणार आहे, कन्व्हेक्शन असणार आहे. आणि कन्व्हेक्शन साठी कुठला लॉ आपण यूज करतोय, न्यूटन्स लॉ ऑफ द कूलिंग. व्हॉट इज द स्टँडर्ड इक्वेशन ऑफ द न्यूटन्स लॉ ऑफ द कूलिंग? Q is equal to H into A into delta T. हे स्टँडर्ड इक्वेशन आहे, आपण अगोदर बघितलेलं आहे. फोरियर्स लॉ नंतर न्यूटन्स लॉ ऑफ कूलिंग बघितलेला आहे. तर तो न्यूटन्स लॉ कशाच्या रिलेटेड आहे, इट इज रिलेटेड टू द कन्व्हेक्शन. सो दिस इज ए हॉट फ्लुइड. ह्या जो एरिया आहे ही डॉटेड लाईन आणि इथला हा जो सरफेस आहे त्याच्यामध्ये फ्लुइड असणार आहे. म्हणजे ह्याच्यामध्ये कुठला मोड ऑफ हीट ट्रान्सफर आहे, कन्व्हेक्शन मोड ऑफ हीट ट्रान्सफर इज देअर. And as we know that what is the standard equation of the convection? Q is equal to H into A into delta T. Okay, तर ह्या hot fluid साठी H काय आहे तर HHF आहे, heat transfer coefficient of the hot fluid into area, आणि temperature difference काय आहे THF minus T1. Okay, so this is the equation number 1. Then we have to write down for this plate. Plate मध्ये काय आहे तर conduction आहे. What is the temperature change? That is T1 and T2. What is the thickness? L. Okay, so by using that we have to write down the equation by using the Fourier's law. Q is equal to K into A into T1 minus T2 divided by L. And similarly for the cold fluid there is a convection, so we have to write down the equation of the convection. So Q is equal to what? Heat transfer coefficient काय आहे cold fluid साठी HCF आहे. So H into A into temperature difference. So what is the temperature difference for the cold fluid? That is T2 minus TCF. Okay, so T2 minus TCF. So write down these three equation, equation 1, equation 2 and equation 3. Okay, so equation 1 is related to the convection, equation 2 is related to the conduction, and equation 3 is related to the convection. समजले का बघा सगळ्यांना? जे काही मोड आहे त्या मोड साठी आपल्याला इक्वेशन लिहायचं आहे. कन्व्हेक्शन असेल तर न्यूटन्स लॉ ऑफ कूलिंगचे इक्वेशन लिहायचं आहे, कंडक्शन असेल तर फोरियर्स लॉ लिहायचा आहे, परत कन्व्हेक्शन आहे म्हणून परत न्यूटन्स लॉ ऑफ द कूलिंग. टेम्परेचर डिफरन्स जो काही आहे म्हणजे हे इथं जर फ्लुइड असेल तर ह्या फ्लुइड साठी टेम्परेचर डिफरन्स काय असणार आहे T2 minus TCF. So in that way we have to write down the equation. Okay, so from equation 1, 2 and 3, write down from equation 1, 2 and 3. झाले ते परत. So write down from equation 1, 2, 3. Write down the equations for the temperature difference. So from equation 1, THF minus T1 is equal to THF minus T1 is equal to what? Q divided by HHF into A. That is the equation number 4. So from equation 2, T1 minus T2 is equal to what? T1 minus T2 is equal to Q into L divided by K into A. Equation number 5. And from equation 3, T2 minus TCF is equal to Q divided by HCF into A. And this is the equation number 6. Okay, then add this equation number 4, 5 and 6. Addition kara. Add this equation number 4, 5 and 6. By addition, we get the equation as a THF minus T1 plus T1 minus T2 plus T2 minus TCF is equal to, take Q as a common. So what is the remaining terms in the equation? 1 upon HHF into A plus L by K plus 1 upon HCF into A. 1 upon HCF into A. Okay. So whatever the addition in the left hand side, so minus T1 plus T1 will be cancelled. Minus T2 plus T2 will be cancelled. So what is the remaining term at the left hand side? THF minus TCF is equal to that right hand side. Okay. So all of you write down equation 4, 5, 6. Then add this equation 4, 5, 6. We get the equation for the THF minus TCF. THF minus TCF. THF minus TCF. THF minus TCF. Okay. इथं बघा, इथं T1, T2, T2, T2 कॅन्सल होणार आहे. So THF minus TCF is equal to this. समजलं का बघा इथपर्यंत? Okay. Then write down this equation. THF minus TCF is equal to area काय असणार आहे? Same असणार आहे. So Q by A we have to take as a common. So what is the remaining? 1 upon HHF plus L by K plus 1 upon HCF. Okay. So from this, what is the equation of the Q? So Q is equal to what? A into THF minus TCF divided by 1 upon HHF plus L by K plus 1 upon HCF. Okay. आता इथं बघा, आपल्याला इक्वेशन काय मिळालंय? Q is equal to A into bracket THF minus TCF divided by 1 upon HHF plus L by K plus 1 upon HCF. Okay. So this is our final equation. Okay. So in this equation, instead of this term A divided by 1 upon HHF plus L by K plus 1 upon HCF, we have put the value as a U. म्हणजे U ची value काय झाली सांगा? What is the value of U? This equation we have written in the form of overall heat transfer coefficient. Okay. So what is the value of U? By comparing these two equations, we get the value of U as a काय असणार आहे? U ची value काय असणार आहे? 1 divided by 1 upon HHF plus L by K plus 1 upon HCF. म्हणजे हा काय आहे तर ओव्हरऑल हीट ट्रान्सफर कोएफिशिएंट आहे. ओके. जे काय आपण सेक्शन कन्सिडर केलेला आहे, फॉर दॅट पर्टिक्युलर सेक्शन व्हॉट इज द व्हॅल्यू ऑफ ओव्हरऑल हीट ट्रान्सफर कोएफिशिएंट. जो काय आपण सेक्शन कन्सिडर केलेला, फॉर दॅट दिस इज द ओव्हरऑल हीट ट्रान्सफर कोएफिशिएंट. ओके. व्हॉट इज द ओव्हरऑल हीट ट्रान्सफर कोएफिशिएंट? 1 divided by 1 upon HHF plus L by K plus 1 upon HCF. जसं आपण म्हणतोय कन्व्हेक्शन असेल तर Q is equal to H into A into temperature difference. So in that manner, instead of H, we have written as a U. ओके, म्हणजे कंडक्शन पण आहे त्या U मध्ये आपण कंडक्शन पण कन्सिडर केलेला आहे L by K आणि कन्व्हेक्शन पण कन्सिडर केलेला आहे. म्हणजे हा त्या पूर्ण सेक्शन साठी काय आहे, ओव्हरऑल हीट ट्रान्सफर कोएफिशियंट आहे. समजतंय बघा, नुसतं कन्व्हेक्शन असेल तर H असतोय, नुसतं कंडक्शन असेल तर K असतोय. ओके, इफ कंडक्शन अँड कन्व्हेक्शन इज देअर, सो ऍट दॅट टाइम वी हॅव टू यूज दिस ओव्हरऑल हीट ट्रान्सफर कोएफिशियंट. म्हणजे जशी काही कंडिशन आहे त्याच्याप्रमाणे तुम्हाला इक्वेशन यूज करायला लागेल. So what is the equation of overall heat transfer coefficient? U is equal to 1 divided by 1 upon HHF plus L by K plus 1 upon HCF. आणि तुम्ही जी डेफिनेशन लिहिलेली आहे तिथं बघितलं तर तुम्हाला कळेल काय लिहिलेलं आहे बघा. While dealing with the problems of fluid to fluid heat transfer across metal boundary, it is usual to adopt an overall heat transfer coefficient which gives the heat transmitted per unit area, per unit time, per degree temperature difference. म्हणजे जर तुम्ही बघितलं तिथे जर U चे इक्वेशन घ्यायचं म्हणलं तर काय येणार आहे, Q डिवायडेड बाय A इंटू THF मायनस TCF. म्हणजे U म्हणजे काय म्हणू शकतोय, रेट ऑफ हीट ट्रान्सफर पर युनिट एरिया पर युनिट टेम्परेचर डिफरन्स, आणि हा टाइम काय इनबिल्ट असतो. ओके, सो देअरफॉर U ची जी काय आपण डेफिनेशन लिहिलेली आहे ओव्हरऑल हीट ट्रान्सफर कोएफिशियंट, ती तुम्हाला U इज इक्वल टू ज्यावेळेला तुम्ही इक्वेशन लिहिता U इज इक्वल टू Q डिवायडेड बाय दिस थिंग, म्हणजे रेट ऑफ हीट ट्रान्सफर per unit area per unit temperature difference. Okay, so that is the definition for the overall heat transfer coefficient. Okay, समजले का सगळ्यांना overall heat transfer coefficient? एक मिनिट. घेताय का तुम्ही? Okay, all of you put your roll numbers in the chat box. Those who are present online. We will stop here. So in next lecture, we have to see the problems on this plain wall and composite wall. So today at 3:30, our lecture is there. So in that lecture, we have to solve the problems on this. All of you put your roll numbers. Do it fast. Anyone is remaining? It's 17:42 ना? 42. तिकडे सांगा. 66, 45, 55, 56, 10, 69, 20, 3, 36, 52, 13, 51, 61, 46, 53, 27, 67, 58, 19, 6, 1, 33, 29, 50, 60, 37, 54, ह्याच्यावरच घेणार का तुम्ही? 8
काढून घेऊन गेले सबाई